All right, here we are, and back in Unit 8, we are now diving into Lesson 15, which has some new vocabulary for us, quartiles and interquartile range. We'll learn more about what those are in just a few minutes, but let's dive into our first activity, which is a notice and wonder activity. It says, here are two dot plots, including the mean marked with a triangle. Notice our little triangles in there. Each shows the age of party goers at a party. Okay, so here's party A and party B, and these are the age of the people that are there. What do you notice and what do you wonder about the distributions of the two dot plots? Well, the first thing I noticed about the distribution in party A is look how many, what is that, like 8-year-olds? There's a ton of 8-year-olds at that party. A couple of 10-year-olds, an 11-year-old or 12-year-old maybe. And then there's a couple of older people over here. A 36-year-old, a 42-year-old, 44-year-olds. Kind of looks to me like, I wonder if this isn't a child's party. Maybe this is an 8-year-old's birthday party, right? Maybe they've got a couple of older friends, right? But I bet this is an 8-year-old's birthday party, and then there's a couple of adults hanging out to chaperone and to make sure everything's safe, right? So I noticed, first of all, and I'm not going to write all this stuff down. You can certainly write this stuff down. I noticed that there's a whole lot of 8-year-olds at this party. And I noticed and wondered if this isn't a child's party because of the ages. We got a bunch of little kids and then just a couple of adults to kind of keep things, in order and not chaotic. But then in party B, the biggest thing I noticed was that there was no big humongous peak, right? These ages are all pretty spread out, right? Yeah, there's some like 6 and 7-year-olds, but there's also a 43-year-old or so, but there's pretty much everything in between. There's lots of different, ages in between there, and nothing really stands out, right? But if you look at the overall spread of both of these, or the distributions of both of these, they're very, very similar to each other, right? Party A is they have a couple of older people, but not really. I mean, it really is very, very similar. But again, this one has a huge spike in young kids, and this one doesn't have any spikes hardly anywhere, right? So those are just some of the things that I noticed that I wondered in Activity 1. How did you do on that? I hope you got it. Let's move on to Activity number 2. This is really fun. We're going to learn about something called the 5-number summary on this one. It says, here are the ages of a group of 20 partygoers that you saw earlier. So can we tell which one this is? Can we tell which party this was? I know which one it was. I think this is data set B because look, there's not all those 8s, right? I only have one 8-year-old, right? So that must be this party. We figured it out. All right, here we go. So, and they put them in order already for us. They put them in order from least to greatest. So as you notice, 7, 8, 9, 10, 10, 11, 12, 15, they're all in order. Awesome. That'll make things quite nice, won't it? Let's move on to number 1. We're going to actually do a bunch of steps here. So that's why I folded this down so it wasn't in my way. Hopefully we'll be able to see all of this on the camera as we're working our way down. And it's going to give us a bunch of instructions here that we need to follow. So let's do each thing. It says, find and mark the median on the table. Okay, so we need to find the median. Okay, now if we remember from yesterday, to find the median, the first thing we do is put all the numbers in order. Well, that's already been done for us, thankfully, so that step is done. Okay, second step is to do the finger squeeze. That's right, we got to do the finger squeeze. So we're going to put our fingers on the first and the last, and we're going to squeeze one number at a time until we either get one middle or two middles. We're just going to take this nice and slow, making sure we're moving both fingers towards the middle. And look at this, we're going to have two middles, but look at what they are. Two middles, but they are the same middle. So the middle, or the median of our data, is right in between those two. So our median is 20. Okay? Now, it says to find and mark the median on the table. So there it is. That's our median. I'm going to label this median. Okay. But it also says to label it 50th percentile. So I'm going to circle that and I'm going to label it 50th percentile. I'm just going to do a percent sign. That's good enough. 50th percentile. This data is now partitioned into an upper half and a lower half. Do you see how we did that? We now have an upper half and a lower half because we literally cut it down the middle. Very, very good. Step A, done. Part B, find and mark the middle value of the lower half of the data. So now we're going to ignore the upper half and we're going to find the middle of the lower half. So once again, we're going to finger squeeze just the bottom half. Okay? So we're going to start on the two ends now of just the lower half. And I'm going to finger squeeze, finger squeeze, finger squeeze, finger squeeze. Oh, we have two middles once again, 10 and 11. Now, what is exactly halfway in between 10 and 11? Does anybody know? Because our middle is right here in between 10 and 11, which is 10.5. That is halfway between 10 and 11. And as you see, there are 1, 2, 3, 4, 5 data points on the left and 1, 2, 3, 4, 5 on the right, so we know we're in the middle. Okay? It says to find the middle value of the lower half of the data, excluding the median. Yeah, we didn't count the median, right? We only counted this from that side on, right? If there is an even number of values, find and write down the average of the middle two. We did that, right? We found that middle of the two middles. Label this value 25th percentile. So this value here is the 25th percentile. Okay, so far so good. Step B is now done. Part C. Find and mark the middle value of the upper half of the data. Okay, again, excluding the median. So we're not going to count this guy, but we're going to count this guy here. So we're going to finger squeeze the upper half now. Okay? So once again, here we go. We're going to finger squeeze really carefully towards the center. Once again, I have two middles, 28 and 30. Now, what is exactly halfway between 28 and 30? Does anybody know? Right in between 28 and 30 lives 29. 29 is the middle of the upper half. Okay? Now, it says find and write down. Yeah, label this value. Oh, we already did. I'm down here on C. Label this value the 75th percentile. So this is the 75th percentile. Well, I see a pattern here. Do you see this pattern? Part C is done. Okay. You have now partitioned the data set into 4 pieces. 1, 2, 3, 4. See that? Each of the 3 values that cut the data are called quartiles. So this is a quartile. 10.5 is a quartile. The median of 20 is also called a quartile, and 29 is a quartile because those 3 numbers cut our data into 4 equal parts or quarters, right? That is 1/4 of the data, 1/4 of the data, or 1/4 of the data, 1/4 of the data, 1/4 of the data, 1/4 of the data, 1/4 of the data. That's where the word quartile comes from. It's literally a quarter of the percentile, right? It says the first or lower quartile, which is this one, is the 25th percentile mark. So we call that Q1 or quartile 1. Okay, so this right here is called quartile 1 or the first quartile or the lower quartile. Okay, the second quartile is the median. So the median is also known as Q2 or the second quartile. So we're going to label that Q2. The median is the second quartile. Those are the same thing. So we have quartile 1 or the lower quartile. The median is the second quartile, or Q2. And I bet you can guess what the third quartile is. The third or upper quartile is the 75th. Am I too low now? Yes, I am. The third or upper quartile is the 75th percentile mark, and we're going to write Q3 next to that one. So this one up here is Q3. Okay? So now D is done. Okay? The last thing we have to do is part E. Label the least value in the set, the minimum. Okay, well, 7 down here. There's my minimum, which makes sense. That's the smallest number, or the minimum. And then it asks us, and the greatest value, label the maximum. So, okay, we're going to go to the greatest value up here. 42 is the maximum. Awesome. Done with part E. We've labeled both of those, the minimum and the maximum. Done. Record the 5 values that you have just identified. These are what are called the 5-number summary. Now, that's what your book calls it. The book calls it the 5-number summary. But I think that's kind of boring. I call it the Big 5. And you'll hear me say that quite a bit, by the way, because I do like to call it the Big 5. Find the Big 5, or here's the Big 5, right? When we're talking about the Big 5, we're talking about the minimum, we're talking about the 3 quartiles, and we're talking about the maximum. So let's fill these in according to our graph here. Our minimum is 7. Our first quartile is 10.5. Our second quartile, or the median, is 20. And our third quartile is 29. And our maximum is 42. So there's our Big 5, okay? That is the Big 5 right there, okay? And that finishes out activity, or number 2 in activity number 2, okay? Let's move on now to number 3 in this activity, and I think it's going to pertain to the same stuff, yes. It says number 3, the median, or Q2, right? Remember, the median, or the second quartile, value of this data set is 20. Yes, that's what we found, right? This tells us that half of the party goers are 20 or younger. Does that make sense? These are ages, right? So half of our party goers are younger than 20, and the other half are older than 20, or 20 or older. Does that make sense? Yeah, that completely makes sense, right? Because that's our middle. So half of them are younger than 20, and half of them are older than 20. Okay, what does each of the following values tell us about the ages of the partygoers? Well, what would the quartile 3 tell us? Well, the quartile number 3 is 29, and if you remember, quartile 3 is what's called the 75th percentile. Well, if the median is the 50th percentile, and that's half of the data, right? Literally 50% of the data, wouldn't this be 75% of the data? So isn't 29 the age where 75% of the data lives? So 75% of the party goers are younger than 29, right? And 25% of the partygoers are older than 29. Does that make sense? Let's write that down one more time. 75% of the partygoers are younger than 29. 25% are older than 29. Does that make sense? Literally, this is 75% of the data, or 3/4 of the data, which is 75%. So 75% of the partygoers are younger than 29, while 25% or 1/4 of the data are older than 29, right? Okay, so now what does the minimum tell us? If we look at this data again on our graph, on our little table, what does this minimum represent? Well, isn't that the youngest person at the party, the youngest party goer? Yeah, that's what that means, right? The youngest party goer is how old? 7 years old. Right? What does the maximum tell us over here? Well, that's the oldest person, isn't it? The oldest party goer is how old? They are 42 years old. That's pretty dang awesome, right? So we know that, for example, 10% of my data are younger than 10 and a half. The next quarter, or the next 25% of our people, are between 10 and a half and 20. The next 25% of our people are between 20 and 29. And our oldest 25% of our people are between 29 and 42, 42 being our oldest person, right? So this big five, these 5 values really do tell us a lot about the data, don't they? And that's kind of why they're called the big 5, because they do tell us a lot about the data. It's a great way to analyze data. Okay, let's keep going. Next here is our Are You Ready for More? So of course that's optional. Not so optional for honor students, but all the same, optional. Let's take a look at activity 15.3. It says, here is a dot plot that you saw in an earlier task. It shows how long Elena's bus rides to school took in minutes over 12 days. We've seen this before, haven't we? So these are her bus ride times. Now, the question actually comes on the next page here. It says to write the 5-number summary, or the big 5. Right? We need to find the big 5. In other words, we need to find the minimum, the first quartile, the second quartile, or the median. Right? We need to find the third quartile, and we need to find the maximum. There are 5 things we need to find. So, let's dive in. Let's do it. First things first, in order to find any of these big 5, we need to put our data. Can we still see our data? I'm going to get all these other papers out of our way. We still need to be able to see our data. Can you still see it up there? According to my figuring, I think we can. All right. So, we need to get our data values and we need to put them in order. Okay? So, let's do that. Our first data value is a 6, and then another 6. And then a 7, and I'm spacing these out on purpose so that we can work. And then an 8, and then another 8, and another 8. And then a 9, a 9, and a 9. And then a 10, another 10, and a 12. I'm going to double check. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots. So there should be 12 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's always a good check, you guys. I know you think maybe I'm wasting time, but if you forget one, what's going to happen to all your answers? They're all going to be wrong, aren't they? So it is worth the time to double check that you didn't miss a dot, okay? So there's our dots. The first thing we have to do is split this data in half, right? The easiest thing to start with is the middle, which is the median, right? We're going to find that second quartile first. To find the median, we are going to finger squeeze, right? So here we go. Finger squeeze first and last. Work our way in, work our way in, work our way in, work our way in. Oh, once again, this activity likes to have two middles, doesn't it? Well, what lives halfway in between 8 and 9? Exactly halfway between 8 and 9 is what? 8.5. That's our median. otherwise known as what? Do you remember? Q2. So 8.5 is our median. Okay? Now, we need to find the middle of our lower half, because that's our first quartile, or quartile 1, right? So once again, we're going to finger squeeze just the bottom half. Now, we don't count this median guy, right? We ignore him. We just start with the next value here. So we're going to finger squeeze from this side towards the middle. Once again, 2 middles. What's halfway between 7 and 8? Well, halfway between 7 and 8 is exactly 7.5. So 7.5 is our first or lower quartile. Okay. Notice how we've split this. 1, 2, 3, 1, 2, 3. Perfectly in half, right? Now we need to do the same thing to the upper half. Now it's really obvious 1, 2, 3, 1, 2, 3, where the middle's going to be, right? But we can always finger squeeze to double check. Yep, it's going to be halfway between 9 and 10. What is exactly halfway in between 9 and 10? Well, it happens to be 9.5, as you know. So that is Q3. Okay? So now we have found the first quartile, the second quartile, or the median, and the third quartile. But that's only 3 of the big 5. What are the other 2 in the big 5? Oh yeah, they're the minimum and the maximum. Those aren't hard. 6 is my minimum, or min, we call it. And 12 is our maximum, or our max. Okay, there's our big 5. 1, 2, 3, 4, 5. How did we do? Do we understand how to find the big 5? It's all about multiple finger squeezes, right? Okay, number 2. The range of a data set is one way to describe the spread of the values in a data set. It is the difference. Remember what difference means? That means subtraction, right? The difference between the greatest and the least, or in other words, the maximum and the minimum data values. So we're literally going to subtract the biggest number minus the smallest number to find what's called the range. Okay, so what is the range? Well, it's going to be 12, which is the maximum, minus 6, which is the minimum. So the range is 12 minus 6, or 6. So the range is 6. Okay, number 3. Another number that is commonly used to describe the spread, so once again, this describes the spread of the values in a data set, is what's called the interquartile range, which is a funny long word. We just call it IQR for short. Interquartile range. Inside or in between the quartiles range. So this is very similar to the range, but now it's only in between the quartiles, which is the difference between, here again, subtracting Q1, the lower quartile, and Q3, the upper quartile. So instead of being a range between the biggest and the smallest, it's the range between the biggest quartile and the smallest quartile. See that? So we're going to take Q3 minus Q1. So what is the interquartile range? Well, it's Q3 minus minus Q1, which is 9.5 minus 7.5, which is called the IQR, and 9.5 minus 7.5 happens to be 2 or 2.0. So our IQR, or our interquartile range, is 2. Awesome. What fraction, part B here, what fraction of the data values are between the lower and upper quartiles? Use your answers to complete the following statement. Now let's think about fractions. I've already actually said this once if you were listening carefully. If we split, if this is our half mark, right? This is the lower half and the upper half. So this would be the upper half and this would be the lower half. We can literally write those as fractions, right? But if we took those halves and then split them in half again, wouldn't this be 1/4 this be 1/4, this be 1/4, and this be 1/4? That's all it's talking about, ladies and gentlemen. We've literally split our data into fourths, 1/4 fractions. Okay, so let's answer this question. The interquartile range, or IQR, is the length that contains the middle blank of the values in the data set. Well, if you remember what the IQR was, it was the distance between Q3 and Q1, right? It was this right here, right? It was 9.5 minus 7.5, if you remember right. It was Q3 minus Q1. So what is the fraction that is within that range? Well, it's 1/4 plus 1/4. What is 1/4 plus 1/4? Well, it's 2/4 or 1/2. Or we can say the word half, right? So let's finish this sentence. The interquartile range is the length that contains the middle half of the values in the data set. Now that sounds kind of funny to say the middle half, but isn't that exactly what it is? Isn't this half of the data that happens to be in the middle? Because it's literally 2 out of the 4/4, so it's half the data, but it's in the middle, so it's the middle half. Usually we think of halves as the left half and the right half, right? But can't we think of this as the middle half? Yes, we can. And that's what it's talking about there in part B, okay? The interquartile range is often called the middle half, okay? Moving right along, we are almost done. Number 4. Here are 2 dot plots that represent 2 data sets. Okay, so here's some dot plots, and here's our next question. Without doing any calculations, predict, part A, which data set has the smaller IQR, or the smaller interquartile range, or the smaller middle half? Well, let's look at the spread of this data. Look how wide this data is spread out. So if I were to find the range, the regular old range, it would be bigger than this range, wouldn't it? See how small this range is compared to this one? Well, if we're only looking at the middle half of the data, right? So we just look at the middle half. Tell me about the middle half of this data. Is it going to be smaller as well? It is, isn't it? So I think, which data set has the smaller IQR? I think it's going to be data set B. Right? Because the middle half is smaller, right? Not so spread out. Right? Okay. Part B, which data set has the smaller range? Oh, we just talked about that as well, right? Range is the whole thing, the biggest minus the smallest, right? So this one, data set A, is much bigger than this one, isn't it? So which one is smaller? Once again, data set B. And I almost wrote that wrong. It's been a long day already, obviously. Set B. Okay, once again, explain our reasoning. Well, this set only goes from 23 to 28. Right? While A, I should do a capital A because that's how it's labeled. Well, A goes from 15 to 28, right? That's a much wider spread, isn't it? Okay, check your predictions by calculating the interquartile range and the range for the data sets. Okay, so let's do data set A over here. We need to find the range and the IQR. And then we're going to do the same thing for set B. I'll give myself plenty of room here. I need to find its range and its IQR. Okay, let's take a look and see if we can figure these out. I actually just realized my camera is about to die, so I'm going to plug it in real fast. Hopefully it keeps recording while I do this. And now we have a nasty shadow of my cords. Let's see if I can get rid of the shadow. Okay. Hopefully that will not disturb anything as we're moving along here. Maybe I should double check. Well, I think we're okay. For set A, let's find the range. Remember, the range is subtracting the maximum minus the minimum. Okay, and I don't know if you could see me up there, but we're subtracting the maximum minus the minimum. So 28 minus, what is that, 15. 28 minus 15, well, 8 minus 5 is 3, 2 minus 1 is 1. So the range is 13 for data set A. Now the IQR. If you remember, the IQR is the quartile 3 minus quartile 1, right? So looking at our data here, we need to find, we need to actually find those quartiles, don't we? And we didn't actually find them. So we're going to have to go back and do that. Let's do the range for B, because we can do that without having to do much. Let's see, our maximum is 28, minus our minimum, which is 23, is 5. Yeah, so we were right. Set B's range is definitely smaller than set A's range, isn't it? Okay. Now all we have to do is find the IQRs of both of these. Okay. So in order to do that, we're going to have to go back to our data sets and find basically the big 5, aren't we? Okay. All right. So the way we're going to do this, I'm not going to bother listing out all the data values to do all these finger squeezes. I think we can do it straight from the dot plot. Now, if it gets too complicated and too hairy scary, then it's worth taking the time to write out the numbers. So let's just see how it goes, and if we need to change our mind, we can. Okay. Data set A, once again, I'm going to use my 2 pencils to do our dot plot finger squeeze. Okay, we're trying to find the middle first, right? So we're going to finger squeeze this. Super careful. We're just going to work our way down the dots. And I hope I'm being super careful. This is the hard part of doing things like this, is following the dots on either side of the graph. It looks like we have a middle, which is 23. Let's double check that. Now this dot went to this side, and that dot went to that side. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on that side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this side. So yes, Q2, so let's label these. We've got our minimum, which actually we already know is 15. Okay, Q1, we don't know yet. Q2, we just found. Q2, or our median, is 23. We don't know our Q3 yet, but we do know our maximum. Maximum is 28. Okay? In order to find the IQR, right, we have to find these 2 numbers. Okay? So we know that this circle right here is our middle. Now we just need to find the middle of the lower half, and that will be our quartile 1, right? So let's find the middle of these dots now. So again, we're going to take this super slow and work our way dot by dot by dot. Dot by dot. We have 2 middles this time, but they both happen to be at 15. So our middle is actually there, with this one going this way and this one going that way, right? But our middle is still 15. Not 15, 17. Gosh, I can't read a graph today. See, our middle is halfway between 16 and 18, which would be 17. Okay, so there's that. Now our upper half, we have to, again, finger squeeze the upper half. So we're going to take this dot, and then we're going to move our way through the dots. Again, we have 2 dots in the middle, but they both happen to be 25. So our Q3 is 25. Awesome. Now, we were able to do that just using the dots. If you got lost in that process, the best way to do it at that point would be just to list out all those values like we did up here, right? Just list them out, finger squeeze them, and find the different pieces. There's nothing wrong with taking the time to do that, okay? But now that I know my Q1 and my Q3, now I can go back to this, okay? My Q3 is 25, so I'm going to do 25 minus Q1, which was 17. So 25 minus 17. 5 minus 17 I can't do, so I've got to borrow. 15 minus 7 is 8. 1 minus 1 is 0. So my interquartile range is 8. Okay, now let's do the same thing for set B. We need to find our IQR for set B now. Okay, and that's down here. So first things first, let's list them all out. We need the minimum. Well, the minimum in this case happens to be 23. Q1 we don't know yet. Q2 we don't know yet. Q3 we don't know yet. But the maximum, we can look on here and know that the maximum is 28. And it doesn't even matter which dot you consider the maximum because we know that they're all 28. Okay? Now, to start, we have to find the middle, don't we? We have to find Q2. So let's finger squeeze. We're going to start, I'm going to start on the top of the stacks and work my way down and in. Okay? So, or over here and here. We're working our way carefully, carefully, carefully down 1 dot each time, right? Until we get to a middle. Now I'm going to go to the bottom of this one so that we can meet in the middle. Okay, so I think this dot is the middle dot with that one going that way and this one going that way. So see how I kind of split that out so that I know which side those 2 dots go towards. And now I'm going to double check that middle. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots on the left side. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots on the right side. So I know that's the middle. That dot is the middle, and it happens to be at 25. So 25 is my median, okay? Or my Q2 value, okay? But I need Q1 and Q3, which means I need to find the middle of my lower half to get Q1 and the middle of my upper half to get Q3. So let's do that. I need my other pencil once again. Here we go. We got to watch out because these dots over here are the ones I need, right? So I'm going to start at the top and work very carefully down through my dots. Once again, be careful to hit every single dot, working your way towards the center. Now, notice, I'm at my last 2 dots. My lower dot is 24 and my upper dot is 25. So what is halfway in between 24 and 25? Well, it's 24.5, isn't it? Okay, again, halfway between 24 and 25 would be 24.5. So that's my Q1. Now Q3 is going to be on the other side, halfway, right? So let's start working our way through these dots. 1, 2, 3. I'm going to go top and bottom. 4, 5, right? Okay, 2 middles once again. So again, in between the 2 middles is my median. My Q3. These dots go to this side, and these dots go to that side. Does that make sense to everybody? But my median, or not my median, I keep saying median. My Q3 happens to be at 27, right? 27 in there. 27. Now I can find my IQR because it's Q3 minus Q1, just like we did before, right? So let's bring this paper back. We need 27 minus 24.5. Now I'm actually going to do that vertically because of the decimal. I don't want to mess this up. So I have to borrow. 10 minus 5 is 5. 6 minus 4 is 2, and 2 minus 2 is 0. So 2.5 is my IQR for set B. There we go. Now we have answered all of number 5. We found both ranges and we found both IQRs. And notice we were right. Set B's both range and IQR are less than set A's range and IQR. So we were correct with our predictions. Woo woo for that. Well done, you guys. That was a fun lesson. We are now done with lesson 15. Ready to move on to the homework problems. Don't forget first to read through that lesson summary, right? Let me get all these extra papers out of my way. So we've got our lesson summary next. First, it goes through a really great example here to walk you through, once again, finding all those quartiles, the inner quartile range, or the range, goes through the idea of the 5-number summary. So just a really great summary of all that vocabulary we just learned. It's a great thing to study, whether you study it today or study it again in a week right before the test. It's a great thing to go back and look at those lesson summaries. But now we are ready for our practice problems. This is going to solidify it in our brains, right? This practice is so important so that the things we've just learned about get embedded even better into our brains, right? And we fully understand and know how to do it ourselves. So go and tackle the practice problems. I believe there are 5 today. Yes, there are 5 practice problems today. Oh, but we are not doing number 5. I forgot to tell you. I think I put it on the module, but we are not doing number 5 because, again, this is one that we skipped, okay, from Unit 7. We didn't do this lesson, so don't worry about doing number 5, but you will be doing numbers 1 through 4 today on this homework assignment, okay? So, oh, there's a number 6 as well. Yes, you are doing number 6. So you are skipping number 5, but we do know how to do number 6, so I do want you to do number 6. Do you see that up there? So skip number 5, but please do number 6. And I'll be back in just a few minutes to go over these homework problems with you. Well done. And as always,
do your best because you deserve your best.
let's dive in and grade lesson 15's practice problems. Here we go. Number 1. Suppose that there are 20 numbers in a data set and that they are all different. Part A. How many of the values in this data set are between the first quartile and the third quartile? Now, in order to answer this question, you have to remember, what is it that we're finding when we find the difference between the first quartile and the third quartile? Isn't that the same thing as the IQR? And isn't the IQR the middle half? Right? So key word being half the data, middle half of the data. Well, what's half of our data? 10. So there are 10 values. Because literally half of our data values have to be between the first and third quartiles. Okay? So if there are 20 data values total, then half of them, 10, have to be in between the first and third quartile. Done. Okay? How many values in this data set are between the first quartile and the median? Okay, now remember, we have the minimum, we have the Q1, we have Q2, which is the median, right? We have Q3, and then we have the maximum, right? Now, if the middle half is here, this is half, right? And we're looking at just between the first quartile and the median, so how much is that? Isn't that a fourth of the data? Literally one of these fourths. So if there are 20 values total, what is 1/4 of 20? 5, right? Each of these fourths will have 5 data values in it, which gives 10 for the middle half, 5 in each quarter. 5, 10, 15, 20, all told. Okay? So that's how you answer parts A and B of number 1. Number 2, in a word game, one letter is worth 1 point. This dot plot shows the scores of 20 common words. What is the median score? All righty. Now, for this one, I am actually going to list out all of the data values, okay? I know that earlier in the lesson we just did finger dots, but I want to show both methods, and I think this is an okay one. There's not a lot of room right here, so I'm actually going to use this space down here. I was looking ahead. Number 3's work is really on the next page, right? So I have plenty of room there to do what I need for number 3. So I'm going to use this space at the bottom of the page on number 2 instead, okay? So let's start by listing out all of our data values. And there are 20 of them, so I do need to make sure my list gets all the way across here. There are 1, 2, 3, 4 fours. So 4, 4, 4, 4. There are 2 5s. There are 4 6s. There are 3 7s. There are 3 8s. There are 3 9s. And then there's 1 22. So I actually made it skinnier than I needed to, but that's okay. Make sure we have all 20. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know I have all of my data. In order to find the median, I'm going to do a finger squeeze. So here we go. See how much easier this is when we actually have numbers? It's a lot easier to finger squeeze. We just take it one at a time in each direction, finger squeezing our way in. Here we go, between 6 and 7. Okay, what lives halfway between 6 and 7? 6.5, and that's our median. Okay, 6.5. So that splits us into our lower half and our upper half. Now we need to split each of those halves to find the first quartile. So once again, we're going to finger squeeze on the lower half. 6 and 4, 6 and 4 again, 6 and 4 again, 4 and 6, and then 5 and 5 are our 2 centers. Halfway between 5 and 5, of course, is 5. So 5 is our quartile 1. Okay, I'm going to circle those just so there's no doubt. Now I need to find quartile 3, which is the middle of my upper half. Now, at this point, we can tell how big our quarters are. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So wouldn't that work up here as well? 1, 2, 3, 4, 5. Cut. 1, 2, 3, 4, 5. Yep. So that's another shortcut. If you don't like finger squeezing and you know what size your quarters are, there you go. So halfway between 8 and 8, our upper quartile must be 8. Okay. Now, part D. What is the... Oh, and we can label the max and the min. Here's our maximum and our minimum. 4 is our minimum, and of course 22 is our maximum. I like to see all of the big 5, right? Now, to find the inner quartile range, I'm taking the difference between Q1 and Q3, right? This is my IQR. My inner quartile range is 8 minus 5, which happens to be 3, okay? So there we go. We just finished up number 2. How many of you got that one right? I hope we all did. Okay. Now on number 3, there are 5 dot plots that show the amount of time that 10 6th grade students in 5 countries took to get to school. We're going to match each dot plot to the appropriate median and IQR. Okay. So that's what we're doing on these dot plots. We've got a bunch of medians and a bunch of IQRs, and we're going to match them to the graphs. Now, hopefully, we won't have to go through all of this for all 5 graphs. Now, could we? Absolutely, yes. We could take the time, and it would actually be pretty awesome if we did, but I don't think we're going to have to. So let's see if we can think of some strategies to lighten the load a little bit. The first thing I want to look at is the medians, and let's see which medians make sense, right? First of all, we know that every single one of these dot plots shows 10 6th grade students, right? So the median is going to be with 5 of them on the left side and 5 of them on the right side. Does that make sense? Because that's splitting it in half. So if I just count dots, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this right in between those 2 dots is my median. So the median on the United States looks like it's somewhere, I don't know, this is 5, this is 10, so maybe 8 or 9. Do we have something that matches that? I bet you 3 is United States. That's my guess right now, just looking at medians. Let's see if we're right. Let's keep going with more medians. Let's look at Canada. Again, we're looking for 5 dots on the left of the median and 5 dots on the right of the median, right? So 1, 2, 3, 4, 5 on the left and 1, 2, 3, 4, 5 on the right. So once again, it's going to split right there. Well, if you look closely, this one falls right here and this one falls right here. So it's actually less than the other one. I'm thinking this one is 7, don't you think? I think this one is Canada. Let's see if this continues to be helpful to us. See how great the median is? Let's do Australia. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's halfway between these 2 dots. Well, what's halfway between those 2 dots? I'm going to mark those 2. Well, this is 15 and this is 20. So what's between 15 and 20? Definitely not 15. Definitely not 12 and a half. What's halfway in between? Yeah, that one right there. 17.5. I think number 1 is Australia. Okay, now we could go backwards and label Australia with the number 1 and label US with number 3 and label Canada with number 4. I don't care which way you do this. Okay, let's keep going. New Zealand is next. To find that median once again, we've got to do the 5 dots on one side, 5 dots on the other. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's between these 2 dots. Halfway between there, right? So what's halfway between 10 and 15? Halfway between 10 and 15? 12 and a half. I think New Zealand is number 5. New Zealand. Which only leads South Africa to number 2, but let's verify that we think that the median is 15. There's 1, 2, 3, 4, 5 dots. And 1, 2, 3, 4, 5 dots. So it's definitely between those 2 dots, which is exactly at 15, isn't it? So yes, that makes sense. This one must be South Africa. Number 2. Now, that's according to the medians. Now, do we think we're going to have a problem if we were to compare the IQRs? I don't think we are, but maybe we should double check. Remember, the IQR is going to be the halfway point on the lower half to the halfway point on the upper half. So let's just try one of these and see. Let's just look at South Africa because they're more spaced out, so it'll be easier to tell. If I'm looking for halfway in between, that means I'm going to have 2 on one side, 2 on the other side. The middle is 10. Is South Africa's IQR 10? South Africa's IQR, oh, no, that's just the lower quartile. Now we need the upper quartile. 1, 2 on that side, middle, 1, 2 on that side, 40. 40 minus 10, yes, is 30. See that? So I think we're safe. Should we check another one? Let's check another one just to be sure. Again, 2 on the left, 2 on the right, there's the middle. So that looks like at about, what, 8, 7.5? 2 on the left, middle, 2 on the right. So this is 15. 15 minus 7.5, this is New Zealand. New Zealand is down here, 8, yep. 15 minus, oh, it must be 7, right? 15 minus 7 is 8. I think we're safe. So it doesn't matter which route you take, whether you compare the medians or you compare the IQRs. If it's hard to tell, maybe you'll have to check them both, but I think I'm pretty confident just having done the medians and the couple of IQRs that we did. I think we're ready to move on to number 4. On number 4, it says that Mai and Priya each played 10 games of bowling and recorded their scores. Mai's median score was 120 and her IQR was 5. So I'm going to write these down just to organize my thoughts here. Mai had a median of 120 and an IQR of 5. Okay. Priya, let's see if I spell her name right, Iya. Priya had a median of 118 and an IQR of, what was her IQR? 15. Okay. It says, whose score probably had less variability? Less variability, less spread out. So we want the more squished data, right? Well, wouldn't that be the smaller IQR? Right? Because the IQR is the distance of that middle half, right? If we look at some of our numbers here, it's the spread, how spread out that middle half is, right? So wouldn't the smaller IQR give us less variability? I think so. So in that case then, Mai would have less variability. Okay, so my scores have less variability because her IQR is smaller. Okay, so there's our answer for number 4. Okay, my scores have less variability because her IQR is smaller. Okay, last one is number 6, and this is a review from quite a while ago. But we can still do this one, of course. It's great review. There are 20 pennies in a jar. If 16% of the coins in the jar are pennies, how many coins are there in the jar? Okay, so let's have C be the number of coins total in the jar. Okay? So because we don't know that, we need a variable for that. Okay. Well, 16% of the coins in the jar, right, are pennies. Does that make sense? Okay, I just literally read the sentence. 16% of the coins in the jar are pennies. I literally just changed those words and kind of abbreviated them, right? That's an equal sign, by the way, because is or are, right, is an equal sign. What does of mean in math? Well, of, as we know, is multiplying. So we're timesing by C, right? Pennies, do we know how many pennies there are? Yes. We know there are 20 pennies. Now the only thing we need to fix is our 16%. We know we can't use that as a percent as it's written. We need to change it to a decimal. 16% is 0.16. So now all we have to do is solve for C, don't we? In order to do that, we have to go backwards to undo the multiplication by division. If we divide by 0.16, that will go away and leave me with C. Divide by 0.16 and I'll get my answer. Now, you guys have a calculator and you're welcome to use it, but I've got to do this the long way. 20 divided by 0.16, I got to move my decimal point twice. So now it's going to be clear over here, right? So 16 into 2,000. Well, 16 goes into 20 once, which is 16. Remainder of 4, bring down the 0. 16 goes into 40 twice, which is 32. Remainder of 8, bring down another 0. If 16 goes into 40 twice, I bet it goes into 84 times. 6 times 4 is 24. 4, 5, 6 is 64. Oh, plus 16. I bet you we'll go 5 times. What's 16 times 5? That's 30. 5, 6, 7, 8. Oh, I was right. It's exactly 80. See, I don't know my 16 times tables very well. But but I sure know how to check my math. So 16 times 5 is 80, so I'm done. 125 is my answer. Did you get that? So what does C equal to 125 actually mean? Because we need to answer this question. Well, isn't C the number of total coins in the jar? So there are 125 coins in the jar. There's our answer. Woo woo! We are done with activity number, what was this? 15. Or practice problems, lesson 15. We are now done with lesson 15. Hallelujah. We are ready for our check your understanding quiz. Dive into that. I bet you're ready. Give it your very best shot. If you have any questions, you can always email me or join me during my office hours. I'd love to see your smiling faces. Dive into that, like I said, and as always,
do your best because you deserve your best.